In this video, we're going to review Unit 3, and this is Part 1. So we need to recognize the 7 types of angle pairs and transversals, which angles are congruent and which are supplementary when parallel lines are cut by a transversal, prove lines are parallel by using the converse, and recognize and apply the perpendicular transversal theorem. So in the figure, line A is parallel to line B, so that's given. And I'll go ahead and make some markings on these so we can see it. Line C is parallel to line D. And so on these, I'm going to put 2 little chevrons to mark. Now, for some reason, when these got printed, some of your numbers got shifted around. And so you'll see some weird numbering right there. Go ahead and adjust it so it looks like mine. Okay, and let's get started. It says name the corresponding angles to the given angle. Now remember, corresponding mean they're in the same position in the angle pairs where the lines cross the transversals. So for angle 10 is in this grouping over here, and we can see that it's in the bottom left-hand corner. So if we look at other groupings, such as this grouping here, the bottom left-hand corner would be a 2. And if we were also to look in this grouping down here, the bottom left-hand corner would be a 12. And so this is going to be angles 2 and angles 12. For angle 1, if we're looking in this grouping here, it's going to be the top left. So it's going to match up with the top left here and the top left in this angle grouping. So that would be 3 and 9. And for angle 15, we're looking at this grouping. It's in the top right. So in this grouping, top right would be 7, and in this grouping, top right would be 13. So 13 and 7. Name the alternate interior angles to the given angle. Okay, so measure, angle 10. This is angle 10. If I want to be alternate interior, all right, all of this region. If my lines are C and D, would be the interior region. If I'm going to be alternate, then I'm going to be on the other side of 10, on the alternate side of this transversal, and so 10 and 15. Now, if I'm looking at these 2 groupings, and C is the transversal, then the alternate side would be 5. Let's take a look at angle 11. Angle 11 is down here. If I'm going to be alternate, would be with 8, or alternate would be with 14. So we'd have 8 and 14. Name the same side exterior angles to the given angle. Angle 13, we want exterior angles. Okay, so again, let's call all of this the interior, and the transversal will be line B right here. So if I want to be same side of the transversal, the same side on the exterior would be angle 16. Now if I wanted to use this as my interior region and the transversal line C, then the same side of this transversal would be angle 1. So it depends on where you're looking. All right, let me get rid of this. All right, let's see, angle 4. Angle 4, I'll get rid of that as well. And don't want to erase the 11. Okay, so angle 4, if I want to use A as my transversal, that would link this grouping with this grouping. The same side, this would be my interior region, so that would be with angle 1. And if I'm looking at this grouping and this grouping with D as my transversal, the same side of that transversal exterior region, this would be the interior, would be 16. Now suppose that in figure 1, line A is perpendicular to line B, but C is not parallel to line D. So let's erase those markings. Name a corresponding angle congruent to the given angle. Okay, so only lines that are parallel cut by a transversal are going to have congruent angle pairs. So let me write that 2 over again. So an angle that is going to be corresponding, congruent to angle 8. Angle 8 is right here. That would be angle 16. One that is corresponding to angle 3. Angle 3, again, here's our transversal. With these being our parallel lines, 3 is going to correspond with 11. And then angle 14, okay, angle 14, we're going to correspond with angle 6, and C will be the transversal. Question 31, it says find the numbered angle measures. So let's see what we've got. Well, first thing I notice is I've got a 45, a 65, and I can figure out what angle 3 is because the 3 angles in a triangle add to 180. So let's figure that out first. Okay, so those 2 angles add to 110. If I want to figure out the third angle in the triangle, whoops, that's going to be 70. I kind of did that reverse subtraction. Let me refix that. Okay, so those are 110, and if I subtract, that's 70. I guess I kind of already got that in my head. So angle 3 is 70. Well, angle 3 is vertical with angle 4, so angle 4 is 70. All right, what else do we know? Well, we've got a linear pair down here because 65 and angle 6 add to 180, so 180 minus 65, and that is 115, so angle 6 is 115. Well, angle 6 and angle 1, if I use these, and these are parallel, they have the little chevron right there, it's going to be parallel, and so I know that these 2 angles are supplementary. And so that means angle 1 is going to be 65. These are same side, interior angles are supplementary, so this is 65. All right, so let me write that down. I've got a 65 and 45. Well, these 2 make 110. That means angle 5 is going to be 70. And 5 is vertical from angle 2, so angle 2 is also 70. And there's more than one way, of course, to answer those. But we will have the same angle measures, just different justifications. In problem 32, it says find the measure of the numbered angles. Okay, so I'm going to kind of start with this bottom triangle here because I see I've got 2 angles and their sum is going to be 140, 80 plus 60. The third angle in that triangle then would be 40 because 180 minus 140 would be 40, so angle 8 is 40. Okay, 8 is vertical from 14, so 14 is also 40. And 12, well, that is a linear pair with angle 14, so angle 12 is going to be 140. Okay, what else do we have? Let's see. I've got a linear pair right over here, so I can say that angle 13 is going to be 100 because 100 plus 80 is 180. Okay, let's see. If I use this as one parallel line and this is one parallel line with this line as my transversal, then I know angles 13 and angle 11 are same side interior are supplementary. So angle 11 is going to be 80. Okay, let's see. I've got, if I'm looking at this triangle right here, I've got a 40 degree, an 80 degree. 40 plus 80 is 120. That means angle 10 is going to be 60 because the 3 angles in a triangle add to 180. Okay, so that means now I figured out what this angle is, which is 100, 40 plus 60. And if I use this as my transversal, same side interior are supplementary. That means the measure of angle 9 is going to be supplementary to 100. and so the measure of angle 9 is going to be 80. Okay, what else do I have? Did I already figure out what measure of angle 10 is? Yes, and that was 60. Okay, we got them all. Name the lines that must be parallel and what postulate theorem is used to prove they are parallel. Okay, I think there was some weirdness over here on this, so I went ahead and said this is going to be for 35 and then for 36. Okay, so for 35, if I know that these two angles are congruent, this angle corresponds with this angle, and A is my transversal, that means I know that C is parallel to D. So C is parallel to D, and that is your corresponding angle's converse. The converse of the corresponding angle theorem is going to state that C and D are parallel. Now in 36, I've got a couple. I can look at line M has an angle here of 89. Line R also has an angle here of 89. Those two would be in corresponding positions, and so I can say that M is parallel to R by the corresponding angle converse. And then I can also say that, let's see, how about this 90 degree is congruent with this 90 degree, so N is parallel to S. And for this one, I'm going to use the perpendicular transversal theorem. And what that stated is if you had two lines intersected by a transversal and the two lines were parallel, and one line intersected at a perpendicular, then the other also intersected at a perpendicular. Now we could also just use the corresponding angles converse as well. Either of those justifications is fine. Okay, in number 37, place a check mark next to any angle pair that can prove two lines are parallel. If you place a check, indicate if the angle pair is congruent or supplementary. Now, linear pair do not prove two lines are parallel. Linear pair are just like this, where you've got an angle here and an angle here. That just means they add up to 180. It does not prove two lines are parallel. Same side interior do, and they are supplementary. And I always remember SS, same side, supplementary. SS, same side supplementary, and those do prove lines are parallel. Alternate exterior angles, yes, those are congruent. Same side exterior angles, that also, same side supplementary, will prove lines are parallel. Alternate interior, yes, and those are congruent. And corresponding angles, yes, those are congruent. Those are angles in the same position in each angle grouping. Vertical angles, those do not prove lines are parallel. Those are just proving that angles are congruent, but nothing to do with lines.